Hey everybody, this is Mr. Munson. We're looking at Unit G.5 congruent triangles. This is concept G.5.6, proven triangles are congruent. A pretty easy chapter. What it is it's going to entail is how do I prove triangles are congruent. There's going to be a hard way and there's going to be a short way. So I'm going to show you the hard way, and then I'm going to tell you, pay attention, I got some shortcuts for you. Okay, so at the very least, what we need to know is there's two triangles in this shape. To prove that those two triangles are congruent would mean that I have to prove that all the pieces down here, there's three sides, have three sides up here that match them. And the three angles down here have three angles up here that match them. So if that's with 30, there have to be a 30-degree angle up there. If that one was 60, it would have to be a 60-degree angle up here. As you can see, we've kind of got started. We got this side is congruent to that side, and that side's congruent to that side. We'd have to come up with some way to prove that those sides are congruent. That's the basic idea that we're going to be working on. Let's get started. I'm going to prove to you that these two triangles are congruent. Now, I do not want to have you write down any of this stuff. I want to show you why this is very involved and why you're going to appreciate the shortcuts I have for you. So first of all, let's see if these two triangles are congruent. Okay, so I'm going to first of all take this information and put it into my drawing. I have AB is congruent to DE. So let's use 3 marks there to show that those are congruent. AC is congruent to CE. Looking over at the drawing, they're already marked. Okay, the same thing is true about BC and CD. Those are already marked. Now they told me AB is parallel to DE, so I'll mark that. Now I need to prove that these two triangles are congruent. That means that for every piece down here, every side, every angle, it has a corresponding piece up here that matches it and is congruent to it. Now the sides, I can see the 3 sides down here have 3 sides up here that match it, but the angles not yet. All right, let me see if I can prove this to you, that the triangles have 3 sides that are congruent and 3 angles that are congruent, and therefore the triangles are congruent. All right, logically, the first line says that AC and CE are congruent. Why do I know that's true? Because it's given. Now notice I have this S written over here. I have these 3 S's here to help you as a reader to know I have 3 lines showing 3 different sides congruent. So that's good. Now I need to have 3 lines showing 3 angles are congruent. That would indicate that the triangles are congruent. Okay, next line. BC is congruent to CD. Okay, BC is congruent to CD. All right, good. That's given. So there's another set of sides. And so on we go. AB is congruent to DE. That's given. Those sides are congruent. Okay, I had to mark those. All right, now I bring in the idea that the lines are parallel. That's given. That's not showing me any angles are congruent. That's just simply saying the lines are parallel. But take a look. If you look at A and E are 2 angles that are congruent. Why do I know that? Because they're parallel lines cut by a transversal. Here's A up here and E down here. So what I find is that this angle right here, that's that one right there, is congruent to this one here because of alternate interior angles. Okay, so we need to get just used to seeing that. We're going to see this figure that I'm working with very often. So just get used to it. If those lines are told to me parallel, or I figure them out to parallel, then I can take this set of angles and mark them congruent because of alternate interior angles. All right, B and D end up being congruent as well for the exact same reason, okay? B and D are congruent because of alternate interior angles. One's on one side, one's on the other between the parallel lines. 7, angle ACB, angle ACB, and this other angle, ECD, okay, that angle, those 2 angles are congruent, and we know that because they're vertical angles, okay? So notice I have my reasoning, and then just after I have an A, an A, and an A. So now you know I have proof of 3 sides that are, pairs of sides are congruent, 3 pairs of angles are congruent. Now I can say these triangles are congruent. And that's because of the definition of polygons. Definition of polygons say, hey, if everything in one shape matches everything in another shape, all the sides are congruence, that show congruence, and all the angles show congruence, then the two shapes have to be congruent. Okay? That's a lot of work. That's showing three sides. If there was a shorter way of doing this, I think I would appreciate it, and that's what I'm here to tell you. That in actuality, if I gave you three sticks, you had a 3, a 4, and a 5 stick, and I gave somebody else those exact same size 3, 4, and 5, and told you to build triangles out of them, and you built them, what we'd find is that those triangles would be exactly the same. The interior angles would match each other. If you had a 30-degree angle in yours, the other person would have a 30-degree angle. They're forced to be the same shape because of only the three sides. We really don't need to know everything about the shape. We only need to know three special things about the shape, and it forces the triangles to be congruent. This will make writing proofs and showing triangles congruent much quicker and easier than showing all three sides and all three angles match up. Let me show you what I mean. In the world I was just showing you, I would have to show that there's three sides in the left figure that match three sides in the other, and three angles on the left that match three angles on the right. I don't have that information. All I have is a 3, 4, 5 on the left and a 3, 4, 5 on the other side. And what I'm here to tell you is that we have a theorem that has some shortcuts in it. This one's going to be called the side-side-side congruence theorem. And what it says is this. There are three sides here that match three sides here. And if that's the case, if I have a 3, a 4, and a 5 pieces of sticks, and I put them together, and then you put yours together, then all the pieces of those triangles become congruent. Well, the obvious pieces are congruent, right? The pieces that you can see are congruent. But what about the angles? Watch closely. Across from the single struck is an angle. That angle there is congruent to the one across from the single struck and the other angle. Across from the double struck is another angle. It's congruent to the one across from the double struck there. And the three strikes. Okay? Now remember those angles are in degrees, and the 3 and the 4, 5, those are in inches, meters. They're completely different units, okay? So whatever this angle is, this one's identical to it. And the reason I can conclude that is because there's a theorem that says, look, I don't know anything about the angles. All I know is the sides. And it's enough to show if you have three sides in one triangle that match three sides in another, then everything has a corresponding part that works out. Every angle on the left has an angle pair on the right, and it's going to sit in exactly the same spot it does in the left. Okay, now that's not the only shortcut. There's several other shortcuts. So I have this kind of good list and bad list. And so hopefully you understand, like in this one here, you have an angle. That's what the A stands for. So you have two triangles where you have two sides that match and an angle that matches, okay? That will be a shortcut. So write these shortcuts down. These are the bad list. You'll see that angle, angle, angle. If I have two triangles with three angles in it and another, that match up, that's not enough to prove the triangles are congruent. This one as well. This one doesn't work as well. And the reason is because it can actually create two different triangles that are vastly different than each other. I'll show that to you in class. But the good news is we don't have to write side, 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 or side, side angle as on our test as a way of proving triangles are congruent. Because if you think about it, if you write it back the other way, that's not good. You don't want to be writing those kind of words down on tests. Okay, so write this down. Put me on pause, get it written down, and then I'm going to show you what I mean by this stuff in the next window. All right, I apologize if I go over the same thing. Again, I somehow didn't push my record button again, so I might go over the same thing. I apologize in advance. I'll go as quickly as I can. Okay? All right, so looking at this, I have two triangles, and what I have marked there is three sides in the top that match three sides in the bottom, and that's enough to show that the triangles are congruent. That means there's an angle, if there's an angle up here, let's say that's 30 degrees, there has to be an angle down here that's 30 degrees. And we'll see how to to match it up in a little bit, okay? Now another shortcut is this one right here, side angle side. Side angle side is this. You have two sides over in one triangle that matches two sides over in the other triangle and an angle that's trapped between them. If you take two sides of some length and open it up the same amount, take two sides and the same amount and open it up, it'll create a triangle where the two triangles are congruent. That means if this side here is 10, it's across from the single struck angle, then this side across from the single struck angle has to be 10. That's awesome. Here's another shortcut. Basically, this one's called angle side angle, and it shows you have two angles with a side trapped between it. So in this triangle here, you have two angles that match two angles over here, and the side is trapped between them. Again, that's a shortcut. If I have that minimal amount of information, I can immediately conclude these triangles are congruent. That means if on this double struck angle, this side across from it was 20, then over in this one where it's double struck angle, the side across from it is 20, even though it's not marked. So sometimes students get careless and they say two angles are congruent and two angles are congruent, and then the side matches the side. And you think, hey, these two triangles are congruent from this. You might call it angle side angle. But see, this is not angle side angle. See, that side right here is not trapped between the two angles. It would have to be this side to be congruent to that side for you to say, hey, these triangles are congruent by angle side angle. Okay? All right, so be careful about that. All right, let's take a look at this one. We have a pair of angles and a side that is not trapped between it, but it falls across or after the two angles. So we have two angles that match, and then a side that's congruent. Now, the side is not just any side. It's the side across from the first angle that we claimed. Okay, so we go angle, angle, side. So over here it goes angle, angle, side. Okay? If I have that information, it forces these triangles to be congruent, and then everything else becomes congruent. The corresponding angles are congruent, sides that are supposed to be congruent that are not marked, they will become congruent, and so on. Okay, let's take a look at this problem and see if you can look at the shortcuts, have them off to the side so you can see them. Look at this problem and see if there's enough information for you to conclude the triangles are congruent. If they are, then we're going to write and learn how to write a thing called a congruent statement. So look at this problem and ask yourself, is there enough information? Now I'll give you a hint. I'm going to have you put me on pause, but I want you to know there is a pair of angles that are not congruent, but you know that they are congruent. So if you can figure out that slight hint, put me on pause, mark those angles congruent, and then the pair of angles congruent, and then look back at your shortcuts and see if you can wrap your head around which shortcut that is. Put me on pause. Now I'm hoping that you mark those two angles right there congruent, right? These two angles are congruent because of vertical angles. I don't need to tell you they're congruent, they're automatic. And when I see this figure, you'll see this figure a lot, I automatically mark those angles congruent to C. Okay, now if I look at that, I see that that is a side angle side situation, right? I have a pair of sides, that match a pair of sides, and the angle is trapped between those two sides, right? Here's these two sides, and it's trapped between them. Here's the two sides, and they're trapped, so that's side angle side. Okay, since those two triangles are congruent, I'm going to need to write a triangle congruent statement. Now let me make sure that you understand what's going to happen here. So I have a triangle ABC on the left-hand side. Always write the first triangle that you write down is always in alphabetical order. But when you go to write the triangle on the second part, it may or may not be in alphabetical order. It depends on how it plays out. So you need to make sure, ultimately, that whatever angle A is, it matches the first angle that you stick here. So whatever first angle you stick here, it should be congruent to that one. B, congruent to that one. C, congruent to that one, okay? So if we take a look at A in the top drawing, we'll see that A is across from the single struck side. So I'm going to come down here to the triangle and find the single struck side, and the angle that's congruent to it should be across from it, and that's why I put E there. Now B, let's take a look at that one. B is here, and it's across from the double struck side. So I'm going to come down here and find the double struck side, and look across from it and see angle D. That's why D's there. And of course, C just ends up being the last one because that's the last one to be left. That's how you write a triangle congruent statement. Order matters, okay? But this one is always in alphabetical order. This one is rarely in alphabetical order. It doesn't have to be. You have to match up the angles and the parts. Now, once you have this, I want you to know it's pretty cool because it's saying that side AB is congruent to side ED. Okay, so AB, this side right here, AB is congruent to DE. It's not marked, but now I can do it. Okay, go ahead and put me on pause and draw this figure down, and then let's walk through it together. Now you can see it's got an answer here already. Let's just pull that off to the side. That will be eventually our answer. It says, are the two triangles congruent? If so, write a congruent statement, okay? So this is what, again, a congruent statement looks like. So let's see if there's enough information for these triangles to be congruent. Whenever I see this picture, I immediately mark these angles congruent, vertical angles. They come for free. Okay, so now I also notice that you have these lines that are parallel. Whenever that happens, I mark the alternate interior angles congruent. Okay, now I just stop. I can mark A and D be congruent, but I don't need to really go any further. If you look at your shortcuts, ask yourself, which shortcut is that? And this is what I notice. It goes angle, angle, and a side. Okay, so if you look at your shortcuts, you have angle, angle, side. Now this is really important. Make sure that it's angle, angle, side here, and in this case the side is across from the single struck angle, that the same flow happens down here, angle, angle, side, with the side across from the same angle. That's going to be really important that you do that. That's the whole thinking part, okay? So now that we have that the triangles are congruent, we now can write a congruent statement. I want you to put me on pause and see if you can think through which angle should go with A and stick it in that first spot, and goes with B and put it in second spot, okay? And see if you can do that one on your own. Put me on pause. And there you have it, DEC, okay? Now ask me a question in class if you didn't get that right, or go back and look at your video why angle A, this one here, would be congruent to this one here. Just look at the geographics of what's going on, okay? For instance, this is the only angle that's not marked congruent to another one, so that means that that one has to be the one that goes with A. All right, go ahead and draw this problem on your work, and then put me on pause while you draw it, and then come back and I'm going to have you do something with it. All right, welcome back. All right, so what I want to do is I want to tell you that these two triangles are stated as being congruent. I don't have to prove that they're congruent using one of my shortcuts. They're already stated. So I need you to be able to mark two triangles being congruent. You need to be able to mark them correctly, okay? So if you look, it says angle A should be congruent to angle C. So let's do that. Let's go angle A to angle C, and then so on. B to D. Okay, we'll use double marks there. And then finally, E has to go with the other one on the other side. Okay? Now, in addition, AB, segment AB goes with CD. So let's mark AB. Now, since this is a triple here, I'm going to go ahead and mark this one with triple. Now, remember, this is an angle and this is a segment, so I'm not saying they're congruent. I'm just trying to keep order to what I'm doing. Okay, so this segment, AB, is congruent to CD down here. And then let's move over, and we have BE congruent to DE, BE congruent to DE. And if you look, that one's across from the single struck side. Let's make it single struck angle, and then this one is single struck. And then that leaves us the last side to be congruent, and so on, okay? All right, very good. Now, looking at these markings, I should be able to write an equation. I can see that this piece and this piece are congruent to each other. So I get to write an equation for that. Now, why am I doing that? Because when I look up here, it says, what is dB? When I look at dB, dB has an expression there with x in it. So I need to be able to plug an x in. That means I'm going to have to write an equation and solve for it. So there I go. So I solve this equation, I get x equals 2.5. Now all I got to do now to do dB is I'm going to plug it into this part and this part to get the full length of dB. I'm going to assume that you can do that on your. Okay, so in a moment, I'm going to show you the do it problems, and I want you not to do them. I think this has been a long video, and you've spent enough time on this. We'll talk about it in class and unfold some more information for you. But I need you to make sure that you have the notes for this when you come to class so that you can talk and understand what we're doing. Okay? All right, so when I get ready to show you the do it problems, don't do them. All right. There you go. And so these are the problems. And so I want you to go ahead and walk through these problems. The last one there, if you don't know how to do it, then go ahead and Google search it and see if you can do it. Okay? All right. Long video. You made it.